This video will be studying about the graphs of ohmic and non-ohmic circuit, then about the fuse wire and also current due to revolving charge. Okay, so starting with graph of ohmic circuit. Okay, you already know this. Okay, this will be what linear graph between V and I, whose slope is going to give you the resistance of the circuit, right? Except current is plotted here. It will be this. Angle is theta, and theta is going to give you resistance with V upon. This will be for ohmic circuit, right? For non-ohmic circuit, this is quite important. Okay, there will be different regions. Okay, where this is going to follow Ohm's law. Okay, where there will be a non-linear variation of voltage with current. Okay, so this is I, this is V. Okay, let me divide in three regions. Okay, first region is in the first region it will follow Ohm's law, means having nature of ohmic circuit. Okay, and then it will be non-linear. So the variation will be something like this. Okay, be like this. This region is having positive resistance. Okay, where your V is increasing with I. Okay, positive. So this region, see, they both are non-ohmic. Okay, from here this is non-ohmic. Okay, up to where it has been. Okay, this region you can say R1. This is positive resistance. R2, this will be what, negative resistance. This will be having negative resistance. Okay, so this was for, this region is for non-ohmic circuit. Write one note here that rho for alloy, specific resistance for alloy will be greater than semiconductor, greater than metal. And one more note is that alpha of alloy will be less than alpha of metal. Right. Now fuse wire. Okay. Fuse wire is basically which we use in old technologies. Now this has been replaced by MCB. Okay. Fuse wire has a low melting point and high resistivity. Okay. Basically, what happens that when there is some kind of short circuit in the electric circuit, this wire is having low melting point. Okay, so what will happen when there is a short circuit? There will be a heating effect of electric current. Okay, so this fuse wire actually melts up and breaks the connection from where the fault has been happened to the whole circuit of the house, or you can say at some other places. Okay, so that there will not be any flow of current. Okay, examples of fuse wire will be uh, they are made up of tin, lead alloys, Now in modern time this has been replaced by MCB, okay, miniature circuit breaker, okay. So this was your about fuse wire, okay. One more topic, that what will be current due to revolving charge, okay. Current due to revolving charge. Suppose the charge Q is revolving on circular path of radius r, okay. What like this, okay. This charge plus Q, you know the time period will be 2 pi r by frequency is 1 by t. That means this will be p upon 2 pi r equals to omega upon 2 pi. Current will be I is equals to nq, okay. Now you can replace this. I will be omega q by pi. N is your frequency, right? That means p q upon pi r. This is your, you can say the velocity, okay, p velocity. And it's rotating with. So this will be your current due to a revolving charge q in a circular path. So these were three basic topics, okay. Drawing graph between ohmic, non-ohmic, fuse wire, and current due to revolving charge. Okay. From the next video, we'll be studying about electrical. Okay.